A rare earthquake warning has some people shaking up across Southern California.
The alarm over a rare kind of earthquake that could shake California harder than anything we've seen before.
The ground beneath California's storied Golden Valleys seems to have whispered its warning, and those whispers have turned into urgent roars. Across a stretch from San Francisco to Los Angeles, the land is showing cracks. Deep fissures mar pavements and open fields alike. Seemingly innocuous at first, these fractures mark an ominous phenomenon as specified by the United States Geological Survey USGS, which has now issued a red level alert. This escalation signals more than just local erosion or minor shifts. It indicates the possibility of serious geologic change in a region long considered tectonically primed. Before we start, smash the like and subscribe buttons for more updates. From the shoreline communities of the Bay Area to the sprawling suburbs and hills of Southern California, the line of visible ground disruption is unnerving in its length and implication. The cracks are not isolated. They run like scars through the earth, suggesting stress accumulation not only on well-known fault zones, but potentially on less acknowledged deep structures beneath the surface. The USGS Red Alert states that, in their assessment, the broad region is under a heightened state of hazard, and although the precise timing and magnitude of what might follow remain unpredictable, the threshold of risk has undeniably advanced. Historically, California has lived with seismic trepidation. The famed San Andreas Fault alone has shaped not only the topography of the state, but the consciousness of its residents. More than a century ago, the major rupture of 1857 left its mark by cleaving open the terrain, and every schoolchild in the Golden State knows the phrase "the big one" as shorthand for the quake that someday may reshape the region. But what makes the present event different is its discursive pattern. Cracking ground along a corridor stretching hundreds of kilometers, not just movement along a singular fault line. The mapping of these new surface breaks shows a continuity seldom seen in quiet tectonic times. Roads buckle at intersections, sidewalks split, chain-link fences tilt, and more ominously, remote tracts of land once thought stable now show offsets and minor heaves. Rural stretches of farmland register fissures that seemingly follow no formally charted fault trace. Urban zones, though built to code with seismic resistance in mind, now face unknown vectors of stress from beneath, vectors that may not yet be defined by the engineers, let alone the insurers. In practical terms, this red alert reshapes more than seismology. It challenges land use planners, emergency managers, county and city governments, and residents in equal measure. Imagine the traffic arteries between Los Angeles and San Francisco momentarily rendered compromised by subsurface motion. Imagine critical coastal infrastructure, oil pipelines, natural gas mains, ports and piers, vulnerable to subtle ground distortion when previously they were assumed to be moderately safe. The red alert means the concept of situational normalcy has shifted. Planning horizons, lifeline systems, and building codes must now reassess, not just for a singular event, but for a region-wide chain reaction potential. Underneath all this is the geology of California. The Pacific Plate is grinding past the North American Plate at a rate of a few centimeters per year. Most of that motion is accommodated by the San Andreas system, the associated network of secondary faults and distributed shear zones. When stress becomes concentrated, especially where faults intersect or branch, surface cracking can occur not only as the direct result of rupture, but as the land above slowly deforms, sinks, tilts, or splits. The appearance of cracking from San Francisco deep into the southern reaches suggests that a larger region of crust is being strained simultaneously, raising the specter of cascading fault interactions rather than a single-line rupture event. One must consider how such ground cracking can also signal the presence of hidden or blind faults, faults that have no visible scar, are unmapped, or are not recognized in infrastructure design. When ground opens unexpectedly, it may indicate that the subsurface strain is escaping where geologists did not expect it. In that sense, this red alert is a signal that the known fault database may be incomplete in reflecting active hazard, and that the region may be entering a phase of unanticipated tectonic behavior. From a human system standpoint, the consequences are profound. The lifeline systems, electricity, water, internet, transportation, are interconnected across the corridor from San Francisco to Los Angeles. Infrastructure vulnerabilities multiply when the ground beneath shifts in unpredictable patterns. For instance, high-speed rail corridors, major freeways, water aqueducts crossing hundreds of kilometers of terrain, bridging fault zones. They all were engineered with known hazard zones in mind. But when the hazard zone extends, cracks appearing in unexpected places mean that retrofitting, routine inspection, and emergency readiness must evolve rapidly. Consider the urban sprawl and population density across that stretch of land. Tens of millions of residents live and work along this corridor. In the event of a major rupture or widespread cracking event, evacuation routes, emergency services, hospitals, and supplies might face disruption. This red alert signifies that an event of such scale is plausible, not just an earthquake localized in one spot, but something overlapping multiple structural systems. Insurance companies, real estate markets, municipal planning agencies will need to factor in this elevated risk, perhaps reassessing property values, zoning, resilience investments, and public communication strategies. The appearance of ground cracking also raises pressing concerns about subsea infrastructure along the coast. Many major oil and gas pipelines travel along coastal routes and across fault zones. Ports in Los Angeles, Long Beach, San Francisco, and Oakland are the gateways for crucial commerce. If the coastline is drawn into the crack zone, then not only terrestrial risk but marine risk becomes real. Seabed movement, liquefaction, submarine landslide triggering are potential auxiliary effects. Coastal lifelines, energy, shipping, fishery infrastructure could be compromised by ground motions not just from a main fault rupture, but from adjacent cracking zones extending inland and offshore. In agricultural and rural areas, the picture is no less troubling. Farmlands, vineyards, and orchards across Central Valley and foothill regions lie atop thick alluvial soils which can amplify shaking, and their subsurface water tables may shift if cracking occurs around irrigation infrastructure. Wells might be damaged, water pipelines could rupture, soil tilting may alter drainage patterns, and thus irrigation systems designed for earlier terrain geometry may become misaligned. The social fabric of farming communities would then face multiple layers of challenge: physical damage, disruption of seasonal schedules, and possible land deformation requiring remediation or abandonment. Farmers often work under tight margins. A large-scale ground movement event could tip many into serious distress. On the scientific side, such a widespread cracking event provides a unique moment of study but also of urgency. Geologists and geophysicists must rush to deploy sensors, map the fissures, measure offsets, monitor continuing motion, and interpret the pattern in near real time. The USGS Red Alert means that monitoring assets must shift from routine schedule to heightened vigilance. Satellite imagery, LiDAR scans, ground-penetrating radar, INSAR interferometric synthetic aperture radar all become priority tools. The sooner the evolution of cracking is tracked, the sooner the dynamics of fault zone interaction may be deciphered, and the nearer a predictive window may come into view. In turn, policy must adapt faster than geology usually allows. Emergency management agencies must integrate the possibility of a multi-fault, multi-zone event into their response frameworks. Shelter-in-place protocols, mass evacuation plans, transportation rerouting strategies must now account for the possibility that large roads may be bifurcated by newly opened ground, or that rail corridors may be unusable for days or weeks. The red alert may require staging of resources across a broader geography, coordination among counties previously considered to be in separate hazard zones, and public messaging to shift from waiting for a quake to preparing for crustal deformation in real time. For business and economic systems, the implications are equally significant. The corridor between San Francisco and Los Angeles is one of the world's richest economic zones. Technology, trade, shipping, agriculture, and creative industries all converge here. A disruption from widespread ground cracking or rupturing faults could ripple through supply chains, logistics networks, ports and airports, and the built environment in a way not fully accounted for. Many businesses have business continuity plans for earthquakes, but few have modeled scenarios in which the ground literally opens across parent fault systems, bisecting infrastructure corridors, and cutting off entire regions from one another for extended periods. Moreover, in real estate, insurance, and finance, this red alert may represent a turning point. Properties built near previously deemed stable zones may now carry elevated risk. Insurers may redraw hazard maps, increase premiums, or withdraw coverage in certain locales. Mortgage lenders may revise underwriting criteria. Developers may face stricter geotechnical requirements or demand new forms of structural mitigation against terrain displacement, not only shaking. The ripple effect can reach property markets, urban planning initiatives, and long-term investment decisions. Another dimension: transportation and supply chain vulnerability. Many major highways such as Interstate 5 and U.S. Route 101 and rail lines traverse the corridor between the two biggest cities in California. These routes were designed with fault crossings and seismic resilience in mind, but perhaps not for the type of widespread creeping ground cracking now suggested. If multiple segments become displaced or fractured, the ease of moving goods, people, and emergency services across the state could drop dramatically. The cost of rerouting, dual tracking, alternative logistics, and redundancy planning will escalate rapidly. The social and human dimension is also poignant. Residents and communities along the corridor may need to shift their perspective, from seeing earthquakes as rare spikes in motion to recognizing long-term terrain deformation as a looming hazard. Schools, hospitals, retirement homes, housing developments may have to revisit their structural safety assumptions. Communities may need to craft dialogue about what safe ground means in a shifting tectonic zone. For many homeowners, the realization that damage may not only come from shaking, but from the ground itself opening beneath their feet will demand mental, financial, and practical adjustments. Additionally, foundation integrity, local zoning, and infrastructure maintenance will take on new shape. Utilities buried under the earth, water mains, sewer lines, electrical conduits, may not have been designed for the kind of ground displacement cracking now forecast. Retrofitting such systems is expensive, complex, and time-consuming. Municipalities will need to inventory and prioritize what must be strengthened or replaced, perhaps accelerating infrastructure bond measures or emergency funds. Engineers may adopt new design codes that treat surface cracking as a first-order hazard rather than a secondary effect of shaking. The psychological toll cannot be ignored. The idea that the earth is stable under one's home, street, neighborhood, so ingrained in all of us, is now challenged. When cracks appear in places not previously considered at risk, people feel unnerved. The USGS Red Alert will likely trigger a wave of heightened anxiety as residents scramble to understand whether their property lies within or adjacent to a newly emerging deformation zone. Public communications will be essential, explanations of the risk, what residents can do, what signs to look for, how to prepare. Without clear messaging, uncertainty breeds rumor, fear, and potential missteps. Yet this moment also presents an opportunity for resilience. While the threat is real, the fact that the USGS has issued a red alert signals that scientists are watching, data is being gathered, and courses of action still remain open. Governments, businesses, communities, and individuals have the chance to act proactively, strengthening infrastructure, backing up essential systems, creating alternative supply paths, rehearsing emergency plans, rather than simply reacting when disaster hits. The metaphorical warning light is now on. What happens next depends on how seriously the region treats the alert and how swiftly it mobilizes. This widespread cracking phenomenon also invites reflection on the broader consequences of long-term erosion of the assumptions underlying seismic safety. For decades, much of California's seismic preparedness has been pitched around major high-magnitude earthquake events. Sudden ruptures, dramatic shaking. But creeping ground deformation, slow but persistent movement, fissuring, surface damage, represents a somewhat newer dimension of tectonic hazard. When cracking is visible across a wide zone, it may indicate that the Earth is steadily transitioning into a phase of readjustment rather than waiting for one clean, explosive moment. In that frame, risk becomes more distributed over time, less predictable in shape, and potentially broader in spatial extent. The geology of California is not new to surprise, but this development suggests that the crustal mechanics of the region may be entering a phase where hidden branching faults and distributed deformation patterns overtake the classic singular fault rupture narrative. If that is correct, preparedness must expand accordingly. Infrastructure, community planning, emergency operations, and personal readiness must all adapt from one big one to many interacting shifts. From a policy standpoint, the red alert raises the question of funding and resource allocation. Should state and federal agencies pivot greater funding into monitoring early warning systems, retrofitting older infrastructure, mapping previously unnoticed faults, updating building codes, supporting homeowners for mitigation efforts? The cost of delaying such decisions may be measured not only in dollars but in lives, in the resilience of communities, and in economic continuity for one of the most dynamic regions of the country. One cannot ignore the impact on the built environment either. Many buildings in Los Angeles, San Francisco, and surrounding suburbs were constructed during eras when the dominant hazard was shaking from known faults. But long-term ground cracking introduces subsidence, uplift, tilt, lateral shift, all of which can undermine structural integrity in ways that do not require immediate collapse, but slowly degrade foundations, piping, connectivity, and safety margins. Buildings that appear sound today may nonetheless carry hidden damage or latent stress from incremental movement. Structural engineers must therefore revisit inspection regimes, modeling, and maintenance schedules. An even broader dimension is the insurance or reinsurance industry's response. California has long been a region where earthquake insurance, catastrophe modeling, and public-private risk sharing are deeply embedded. With cracked ground over broad swaths, risk models must be revised. Premiums may rise in areas previously considered relatively safe. New geographic zones might be added to high-risk stratification. That may influence property markets, development decisions, lending terms, and ultimately how people choose where to live and invest. For agricultural landowners, water districts, municipal utilities, and rural communities, the emerging cracking pattern may lead to complicated decisions. Should irrigation canals be realigned? Should wells be shored up? Should utility lines be evaluated for shift tolerance? When ground movement occurs slowly, adaptation is possible, but only if the movement is recognized early and the systems are sufficiently flexible. The red alert means those decisions should now be on the table. An allied concern is the environmental and ecological impact. Ground cracking can alter drainage patterns, accelerate erosion, create new springs, or disrupt existing aquifers, and thus affect habitats, wetlands, and ecosystems. Wildlife corridors and protected lands that were once stable may now face new terrain instability. Coastal habitats may be endangered if subsurface shifts cause shoreline retreat or trigger submarine instability. At the heart of all this is time. Time to respond, time to adapt, time to begin mitigation before the worst happens. The issuance of the USGS Red Alert is a temporal marker. It defines a now, if you will, a regime of elevated risk rather than something off in the distant future. The sooner the various sectors, government, infrastructure managers, business, residents, align their readiness, the higher the chance that the region will emerge from this phase with stronger resilience rather than aftershock trauma. Importantly, the public should not conclude that the cracking automatically means an imminent Armageddon scenario. Geologic processes unfold on varied timescales: minutes, hours, days, months, years. The red alert simply reflects that the likelihood of a significant event or series of events has increased. It does not define the exact moment, magnitude, or nature of that event. That uncertainty is exactly why preparedness becomes so important. We cannot predict precisely when the next big rupture will occur, but we can choose to be better prepared this time, more informed, more adaptable. Education and communication will be crucial. Residents and communities must shift from thinking solely in terms of earthquake drills to thinking in terms of ground deformation readiness. People should know to look for surface cracks, tilted walls or utility poles, misaligned sidewalks, separated driveways, or sudden changes in drainage. Local agencies might publish maps of the cracking zones, advise on shoring foundations, monitor pipelines for movement, and coordinate with utilities. Communities already prone to wildfires, drought, and flooding now must add tectonic deformation to their cocktail of concerns. Scientists now turn their focus toward the subsurface data streaming in from dense arrays of seismometers and GPS stations, searching for subtle indicators of stress redistribution that may explain why the crust is fracturing so widely. Deep Earth imaging has revealed zones of anomalous heat and fluid migration that could be weakening fault boundaries, potentially allowing new fractures to propagate where none existed before. These discoveries hint that the entire tectonic framework beneath California might be undergoing a slow, transformative shift. As the red alert galvanizes attention, new technologies are being tested in real time. Drone-based mapping, AI-driven crack detection, and automated satellite analysis feeding continuous updates to monitoring centers. This fusion of geophysics and machine learning offers the possibility of recognizing patterns before they cascade into catastrophe. In universities and field labs, teams collaborate across disciplines: engineers, climatologists, urban geographers, each trying to understand how such crustal instability may interact with climate-related stressors like groundwater depletion or extreme heat. The phenomenon is no longer treated as an isolated geological episode, but as part of a dynamic, evolving system where Earth processes, infrastructure, and human settlement are inseparably linked. The red alert, therefore, has become both a scientific challenge and a societal reckoning. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on California's ground cracking from San Francisco to Los Angeles? We want to hear from you. Thank you for watching and see you next time.